Hello, I'm Nick, and this is Today in Philosophy of History for Sunday, 9 November 2025. It is the 140th anniversary of the birth of Hermann Klaus Hugo Weyl, better known to posterity simply as Hermann Weyl, who was born in Elmshorn near Hamburg on this date in 1885. Weyl was a mathematician and a theoretical physicist. In these roles, he was extraordinarily productive, and he's left his name on at least a couple of dozens of ideas in mathematics and physics. For these contributions alone, Weyl will be remembered as long as human beings or their successors are engaged in doing science. Weyl also wrote occasional pieces on philosophy, including writing about the philosophy of time. There are a couple of volumes collecting his occasional pieces: Mind and Nature, Selected Writings on Philosophy, Mathematics, and Physics, which is mostly philosophical, and Levels of Infinity, Selected Writings on Mathematics and Philosophy, which is mostly about mathematics. Most of what I'll have to say today is derived from the papers in these two books. Previously, in my episode on Hans Reichenbach, I discussed Reichenbach's philosophy of time in relation to philosophy of history, and I'd like to do something similar with Weyl. To do that, I'm going to try to fill in some background of Weyl's views on philosophy of logic and mathematics, which isn't usually what I talk about, so I want to try to give some sense of his views on the methodology of the formal sciences to make his position more comprehensible. It's relevant, but even if it doesn't seem relevant, it interests me, so I'll talk about it anyway. Reichenbach's thought, in contradistinction to Weyl, is kind of what you'd expect from a scientist who became involved in philosophy. He reflected the reigning logical and scientific orientation of philosophy in his time, and he brought his own scientific attitude to bear on philosophical problems. Weyl was strikingly different from Reichenbach in this respect, more like Kurt Gödel. Despite his contributions to science and mathematics, Weyl's philosophical interest ran to idealism, reading Fichte and early modern mystic Meister Eckhart. In his autobiographical lecture, Insight and Reflection, delivered in Switzerland in May 1955, he told his audience, quote, "Of all spiritual experiences, the ones which brought me the greatest happiness were the study of Hilbert's magnificent report on the theory of algebraic numbers as a young student in 1905, and in 1922 the reading of Eckhart, which captured me during a marvelous winter in the Engadine," unquote. Again, like Gödel, he was influenced by Husserl and phenomenology, and very directly so. In my two episodes on Husserl, I've discussed his philosophy of history and a philosophy of history that can be derived from his extensive writings on time. Weyl doesn't discuss these writings and certainly doesn't speak directly to Husserl's philosophy of history, but the influence of Husserl on Weyl was so pervasive that Weyl mentions Husserl in his book on the continuum, a critical examination of the foundations of analysis. But we shouldn't be surprised by this. There's a fundamental consonance between the phenomenological method and Weyl's conception of the methodology of the formal sciences. For a time, Weyl adopted a modified form of constructivism in his mathematics, something he had in common with several mathematicians who were influenced by Husserl. Weyl eventually softened on his constructivism, but his book, The Continuum, embodied both his constructivism and the influence of Husserl. Here we should recall that Husserl began as a mathematician, and much of his philosophical work was focused on clarifying the foundations of scientific knowledge, so it was, in a sense, pre-adapted for reflection on mathematics. It's not easy to give a simple summary of constructivism since there are several forms of constructivism. It seems to me that we can break down the three most familiar forms of constructivism into the following categories. First of these is intuitionism, which is associated with restrictions on logical methods used in mathematical proofs, like the law of the excluded middle, that is to say, P or not P, and double negation, that is to say, double negation being equivalent to affirmation. Intuitionism was the brainchild of Dutch mathematician L.E.J. Brouwer, and Weyl wrote of Brouwer, quote, L.E.J. Brouwer, by his intuitionism, had opened our eyes and made us see how far generally accepted mathematics goes beyond such statements as can claim real meaning and truth founded on evidence, unquote. The old joke is that an intuitionist won't agree that either it is raining or it's not raining until he's looked out the window. The second form of the forms of constructivism that I will outline today is what we could call the exclusion of impredicativity, where a part is defined in terms of a whole of which it is a part, which is also known as the vicious circle principle. This predicativism is associated with figures as diverse as Bertrand Russell and Henri Poincaré, so it's much less niche. It's a much less niche position than intuitionism. Weyl discusses predicativity in his book On the Continuum, but he also says, quote, in spite of our agreement on certain matters, Russell and I are separated by a veritable abyss, unquote. Thirdly, among the forms of constructivism is finitism, which excludes all infinitistic formulations, or, as is sometimes said, any reference to the infinite as a completed whole. Intuitively, it seems like there ought to be only one form of finitism, since it seems like the law of the excluded middle ought to apply here, so either you use the infinite or you don't, but that's not actually the case. There are a great many forms of finitism depending on how strictly you interpret the finite. Per Martin Loff writes that epsilon zero is, quote, an ordinal about whose constructive accessibility nobody has any doubt, unquote. Epsilon zero, and I'm not talking about the physics sense of vacuum permittivity, but the epsilon number sense, that is to say, epsilon zero is the limit of transfinite recursion. So saying that it's constructively accessible is, we could say, a very permissive form of constructivity. Others call themselves strict finitists, which Matthew Marion has called, quote, a radical form of constructivism, and some call themselves ultra-finitists. I've made this tripartite distinction among forms of constructivism because I find it useful, but they're not mutually exclusive and they may all flow from a common motivation. Impredicativity is excluded because it's self-referential, and self-reference is, in a sense, infinitely circular. Intuitionism excludes the law of the excluded middle because it creates problems with respect to any infinite domain. So we could say that constructivism generally is concerned to avoid paradoxes generated by infinitistic forms of reasoning. Brouwer's philosophical writings make for a fascinating reading given his curious mixture of mysticism and misanthropy, but this hasn't had anything like the influence of his intuitionism. Michael Dummett gave what is perhaps the most pithy summary of intuitionism, which is this, quote, from an intuitionistic standpoint, mathematics, when correctly carried on, would not need any justification from without, a buttress from the side, or a foundation from below. It would wear its own justification on its face. Since classical mathematics patently did not have this character, what was needed was not to prop it up, but to reconstruct it, unquote. This is exactly what Husserl wanted not only from mathematics, but for the whole of human knowledge, or at least foundations of human knowledge. Knowledge should wear its justification on its face in the form of being intuitively given and utterly transparent. Weyl had his own form of constructivism that overlapped with Husserl's phenomenology, and it was a moving target since he changed his position over the years. I said earlier that he softened his formulations of constructivism as time went by. In a posthumously published paper written in 1953, Axiomatic versus Constructive Procedures in Mathematics, he explicitly contrasts axiomatics and constructivism as distinct, but also, in a sense, complementary methods of mathematical research. Given the restrictions that most forms of constructivism impose on mathematical methods, I was surprised to find in this paper a remark that Weyl attributed to Felix Klein, under whom he is studying at Göttingen. Weyl reported that Klein said, quote, "Suppose I solved a problem. I have taken a hurdle or jumped a ditch. Then you axiomaticians come around and ask, can you still do it after tying a chair to your leg?" Unquote. We've already seen that constructivism usually involves some restrictions on the use of logical methods in proof. Carnap called these restrictions negative requirements in his Logical Syntax of Language, and many mathematicians have found these negative requirements too burdensome, to the point where they will even reject constructivism when they are sympathetic to it. But Weyl's quote from Klein implies that some mathematicians also find the requirements of axiomatics too burdensome, maybe even as burdensome as tying a chair to your leg, and there's admittedly a striking artificiality about axiomatic thinking, but constructivist thought has its own kind of artificiality, as I've already discussed. However, constructivism was conceived as a way to keep a mathematical practice in direct contact with intuitive evidence. Constructivism appeared as a response to the puzzles that started to be discovered in mathematics in the 19th century, often as a consequence of the attempt to improve the formulations of mathematics. When Kant formulated his epistemology, Newtonian physics was the paradigm of natural science, and Euclidean axiomatics was the paradigm of mathematics. But it wasn't long after Kant that non-Euclidean geometries were discovered. Apparently, the time was ripe for it, since non-Euclidean geometries were independently discovered by at least 4 mathematicians: Carl Friedrich Gauss, who didn't publish his results, the Russian Lobachevsky and the Hungarian János Bolyai, who both formulated hyperbolic non-Euclidean geometry, and Bernard Riemann, who formulated elliptic non-Euclidean geometry. Riemann's elliptic geometry and the metrical method he used to obtain it eventually went on to become the setting of general relativity, so we can see that the formulation of non-Euclidean geometry wasn't merely some mathematical curiosity that had no relevance beyond those doing pure mathematics. Bolyai and Lobachevsky, by contrast, used Euclid's axiomatic method and obtained their hyperbolic non-Euclidean geometries by changing the axioms of geometry, specifically by changing the axiom of parallels, which had been a sore spot for mathematicians for 2,000 years. This is interesting in relation to Weyl, because Weyl explicitly discussed the axiomatic method not merely as a tool, as a technique of exposition, but as a tool of mathematical research. And the work of Bolyai and Lobachevsky exemplify the use of axiomatics in mathematical research. The upshot of the conceptual revolution that was non-Euclidean geometry was that the geometry of Euclid wasn't the only geometry that was possible, and Euclidean geometry wasn't necessarily the geometry of the space that we inhabit as spatially extended bodies. A distinction came to be made in geometry between physical geometry and pure geometry. Physical geometry is an empirical question, and since the distinction was made, cosmologists have been attempting to determine the actual geometry of the universe. Pure geometries now represented exercises in formal thought, all of which can be made as rigorous as Euclid, and as was to be discovered with the revolution in rigor, they can be made more rigorous than Euclid, but none of them is privileged in the way that Euclidean geometry had been privileged in mathematical research when it was presumed to be the unique geometry that also described physical space. What was found to be the case with space, that is, that a distinction had to be made between physical space and pure space, could also be applied to time. That is to say, we can make a distinction between physical time and a pure time. Physical time is an empirical question that can be studied by the methods of natural science, as physical geometry can be studied by the methods of natural science. Pure time, on the other hand, is a theoretical construct, and it could take any formal structure that we imposed on it. The distinction between pure time and physical time has profound implications for history insofar as history is a function of time. So in what way is history a function of time? In my episode on Hans Reichenbach, I formulated what I called 4 permutations of the historical supervenience thesis, according to which history supervenes on time. I went back to that episode to see what I'd said, and now I'm not so satisfied with it. I thought I could give this a further exposition today, but now I see that historical supervenience needs a lot more work. But the basic idea is that changes in history aren't possible without there also being changes in time. The metaphysics of supervenience came about as an attempt to give an account of mind and also morals without being reductionist, but also without ceding any ground to idealism or some non-naturalistic account. Reductionism had its heyday in the 20th century, and a reaction subsequently set in against it, driving efforts to find non-reductive ways to do justice to appearances that had been dismissed to make way for scientific realities. A set of properties A is said to supervene upon another set of properties B when there cannot be a difference and in A properties without there also being a difference in the B properties. If the A properties are the properties of mind and B properties are the properties of the brain or some other material substrate for mind, then there are no changes to mind without there also being a change to the brain, which would mean that mind closely tracks the brain, but isn't necessarily reducible to it. So that's a very rough and ready version of supervenience, and there are many books that will give you the longer version if you're interested. But we can say the same thing with time and history if we say that A properties are the properties of history and B properties are the properties of time, and there can't be any change in the A properties of history without there also being a change in the B properties of time. That's what I mean by the supervenience of history upon time. Again, this is a very rough and ready formulation, and I don't have any dogmatic attachment to it. It's just a way to talk about the relationship of history to time, avoiding reductionism while maintaining connection between two manifestly closely related things. If I thought more about this, I would probably prefer a formulation in terms of emergence than a formulation in terms of supervenience, but I'll talk about that another time. In any case, that history is a function of time can be expressed in many ways, one of which is that there are no changes in historical properties without there being changes in temporal properties. Maybe it would be easier just to say that if there were no time, there'd be no history. I think that's essentially in the spirit of supervenience, even if the formulation leaves much to be desired. It cuts a lot of corners, you could say. Time is the basis of history, then, and time has been an object of intense study and research by philosophers and scientists, with the most recent science pointing to a distinction between physical time and pure time, analogous to the distinction between physical geometry and pure geometry. So what ought the relation to be between a physical time and a pure time? With this question, I come to Weyl's 1927 paper, Time Relations in the Cosmos, Proper Time, Lived Time, and Metaphysical Time. Weyl's tripartite distinction among proper, lived, and metaphysical time doesn't directly map onto the distinction between pure time and physical time, but I think it is intended to address the problem raised by the distinction. And I should say that Weyl's treatment isn't how I would approach the problem, so I'll try to give Weyl's treatment a fair shake, but since it's not how I see it, I'm liable to get some parts of it wrong. Proper time for Weyl is time as it's understood in contemporary science. His exposition of proper time, which takes up most of the paper, is framed in the now familiar language of physics. We can get a flavor of Weyl's proper time from this, quote, "The possible space-time locations or world points form a four-dimensional continuum in the mathematical sense," unquote. And, quote, "If a four-dimensional continuum is referred to by coordinates, then in this way it is described by the four-dimensional number space and the continuum of all quadruplets of numbers," unquote. And, quote, "The separation into past and future, into that part of the world into which actions can reach out from O, and that part of our actions can reach to O, is brought about not through a stratum, but through a cone-shaped figure whose apex is at O, the light cone. The intuitive comprehension of these relations does not cause the least difficulty if one always inquires about the possible effectual relationship of two events instead of their time relation," unquote. In contradistinction to this proper time formulated in the language of natural science, lived time is described by Weyl in this way, quote, "Lived time is an enduring now filled with changing contents, but every momentary phase of the lived is changed from the mode of now being to the mode of just having been. This subsidence into pastness, captured in retention, like the protension of the future, rising up into the present, belongs to immediate time life as well. On the other hand, reminiscence is an act of bringing to mind elements of consciousness that, as already lived, have disappeared. There here already are constituted objective structures whose sensual content is held as identical, independent of the to be lived," unquote. In my episode on Wilhelm Dilthey, I talked about Dilthey's conception of lived experience, but it seems that Weyl didn't get the idea of lived experience from Dilthey, but since he doesn't mention Dilthey, I couldn't find a reference to Dilthey in Weyl's writings, but rather he seems to get it from Husserl. And Husserl's lectures on time consciousness are full of references to lived experience, although Husserl doesn't actually use the phrase lived time, gelebte Zeit in German, but he uses a lot of close equivalents. For example, as when he writes, quote, "The primordial temporal field is by no means a part of objective time. The lived and experienced now, taken in itself, is not a point of objective time," unquote. Eugene Minkowski, not to be confused with the Hermann Minkowski who made an important contribution to relativity theory. So Eugene Minkowski wrote an entire book on lived time, but while it captures some of the spirit of the idea of lived time, it's very much a continental production, and it originally appeared in 1933, 6 years after Weyl's paper that mentions lived time. So I haven't yet tracked down the first use of lived time, but I'd be interested to know the exact source of it. Beyond proper time and a lived time, metaphysical time for Weyl is what holds proper time and lived time together. Quote, "Metaphysical time comes forward as the connecting link between objective time, the mathematical ordering scheme of the world points on the world line of the I body, and time lived by me. Of course, the objective world, expressible only in mathematical symbols, can only be won from the given in experience, through abstraction, objectification, totalization, projection on the horizon of the possible. If one severs this connection, there remains a pure play of signs without meaning. But even if in this way what is given by consciousness is epistemologically prior, still reason cannot help positing the objective world as that which is prior with respect to the grounds of being. Metaphysics is the attempt to accomplish this reversal," unquote. So for Weyl, we have these three kinds of time, proper, lived, and metaphysical, where proper time is time understood scientifically, lived time is time as it is experienced, and metaphysical time is the connecting link between the abstract expression of time and this concrete experience. It's always been one of the great problems of science that, in spite of its appeal to empirical evidence, experience is often radically at odds with scientific formulations, so that a considerable effort is required to see the world as science seems to demand that we see it. The scientific expression of time, which Weyl calls proper time, is radically different from the lived experience of time, and that means we stand in need of some way to bring the two together. And for Weyl, this is metaphysical time. Weyl is troubled by the apparent reliance of his temporal framework on the punctiform present, that is to say, the present as an unextended instant that is the boundary between past and future. He writes, quote, "The point nature of the now within the time continuum raises a certain difficulty with the conception of metaphysical time. For within a continuum, a point, without the neighborhood through which it is bound to the whole continuum, is not capable of existence." Unquote. The remainder of the final paragraph of the paper offers a couple of suggestions toward a resolution of this problem. One suggestion is to treat physical particles as themselves unextended, though being reducible to fields. The other suggestion renders this in philosophical language. Quote, "Then there is no point like now, and also no exact earlier and later. Roughly speaking, then things act as if the life point bound into the body, which awakens the objective world into existence for consciousness, possesses not only a diffuse spatial extension, but also a diffuse temporal extension. The immediate present is no longer entirely abrupt. There is always a small halo, quickly fading toward the past and toward the future, along with the self-shining light of immediacy." Unquote. This is essentially the Husserlian idea of the present being extended into the past by retention and into the future by protension. I don't find either of these formulations of Weyl to be especially helpful. And whenever the punctiform present comes up and it is perceived to be a problem, the suggestion is made that it's actually a little fuzzy and that the present is extended a little way into the past and a little way into the future. I don't take this to be a successful argument, but I'm not going to dwell on it any further now. What's interesting here is Weyl's distinction between proper time as scientific time and lived time as experienced time, and metaphysical time being the glue that holds it all together so that we can have our science and our experience too. In this way, we avoid the reductivism of saying that time is experienced as mere appearance, while the proper time of natural science is reality. But this comes at the cost of introducing metaphysical time as the structure that holds all three kinds of time together. So I leave it as an exercise to the listener whether the greater sin is to implicitly invoke the metaphysical distinction between appearance and reality, as conventional science does, or to introduce metaphysical history to smooth over the distinction, as is implied by what Weyl does. Whatever we think of Weyl's three kinds of time and the relationship to each other, they point to a potentially interesting way to analyze history. From each of Weyl's forms of time, we can construct a form of history. And Weyl himself gives a sketch of history framed in terms of proper time. In his philosophy of mathematics and natural science, he wrote, quote, "All simultaneous world points form a three-dimensional stratum, all world points of equal location a one-dimensional fiber. According to this view, we may describe the structure of the world as possessing a stratification whose layers are traversed by fibers. Though each world point runs through one stratum and one fiber, any one fiber intersects a stratum in but a single world point." Unquote. There's a very similar passage to this in the essay that I've been discussing as well. So this is a very abstract account, like something you would expect from astrophysics, and seemingly more than a little awkward for history, but certainly not impossible. for history to make use of. A conception of lived history derived from Weyl's lived time poses certain problems. In what way does lived history differ from lived time, if any? Is it only the duration of time that matters, so that if one lives a long life, then one acquires a sense of lived history, but if one is unfortunate enough to die young, one doesn't acquire that sense of lived history? This might be one way to approach lived history, but I think it would be more promising to consider lived history as lived experience that is experienced in a given context understood to be historical. We often hear the phrase eyewitness to history, and this implies that someone has experienced an event regarded to be of sufficient importance that it will be a part of the permanent historical record. We could understand lived history as the totality of eyewitness experiences of an historical event understood as an historical event. Thus, a single eyewitness account is just lived experience, but when there are many such lived experience of an event that can be taken together, however it is we take them together, then that is lived history. This account isn't without problems. It leaves an open question about historical events that are witnessed by a single individual who leaves a record of them, and the nature of how exactly we're taking these lived experiences together as a whole. I don't think that these are insuperable problems, but some effort would be needed to clarify this through a better formulation that makes the historical context the key distinction here. A conception of metaphysical history derived from Weyl's metaphysical time would be the connecting link between the proper history of a more or less physics account of how the world functions and the lived history account that I've just attempted to outline. Here, with history, I think the result is a little happier, a little more coherent than that with time alone, that to which Weyl gives an exposition. Metaphysical history can supply the framework that serves as a historical context, knitting together individual lived experience into a historical whole and inserting them into proper time, which can be precisely measured. No one would likely want to write history as apparently would be dictated by the scientific account of proper history, but it could form the organizing principle for the context in which lived history is to be constructed, and the combined whole would be metaphysical history. And this, I think, constitutes an interesting approach to history. So happy birthday, Hermann Weyl, and thanks for listening.